We got 5. Yes, you're right.
Wait, is there 5?
Okay, that's what I got too.
Oh, when did you?
Just now.
Did you just walk in?
Like just now.
Why did I just not notice you walking in your time?
Alright, for number 5, the first thing you need to know is that this is written a little weird. You could rewrite it. Now, your asymptotes. You have to think about what were your original asymptotes for cosecant. So if I'm going back to using my table, I'm so all of our asymptotes for where sine was 0, so that was here, here, and here. So those asymptotes are either going to stay there or they're going to change. Do we have any horizontal transformations? Yeah. No. So they're not going to change. My y's are going to be affected, but that's not going to change where my asymptotes are. So at your multiples of pi, pi k. That's your answer. If you did have some horizontal transformation, you could apply that to your x's. Wherever those new x's moved it to would be your new asymptotes. I'm going to say this as a hint. Number 2 is a trick question. So make sure you have this written down. And then
Yeah, 3. Just a hint.
2 pi over b.
That's a formula, not a hint.
No, that is the hint.
It's
So
so
your answer, Logan. Logan.
No, that's what we wrote, but I don't know how I lost it.
It's make sure you have this written down and pass it answer sheets.
But isn't the B 2? It's just pi. It's just pi. I'm serious.
For number 1, you didn't really need to do any work because that was on the unit circle, so you could have evaluated it from there. So 1/2. Some of these, my work extended to the back, so I'll come back to number 2. Number 3, my 2 angles, I got 3 pi over 12, 4 pi over 12 to get me pi over 4 and pi over 3. So my exact value was √2 plus √6 all over 4. For number 3, I'll come back to number 2.
You have to multiply the bottom. You were just 2.
I'm done.
I'll come back to 4 and 5 because those are on the back. But you can see the angles I use. So number 2, I use 135 and 30. Number 4, I use 8 pi over 12 and 9 pi over 12, which gave me 2 pi over 3 and 3 pi over 4. For 5, I use 60 and 45, but you could have also used 45 and 30 or anything else on the unit circle that gave you 15. For 6, I use pi over 4 minus pi over 3. Yes, that's right. To get the same thing for 3, √2 plus √6 all over 4.
Where's the number?
I just have this.
Okay.
Sorry, can you scroll up?
Hold on 1 second. So number 2, negative √6 minus √2 all over 4. I'm going to talk about 5 here in a second. If you have those switched, that's fine. As long as it's they're both minus.
No, but it's not. That's what I'm saying. I have it negative, but plus. Like, I have to see it. So
For number 4, really I did way too much.
I really messed this up. I really done this all. I thought there's only 3 of them. How did you get
Really, you should have that answer. You shouldn't have anything else. Remember when I said I don't need you to keep going? The reason why is it's a lot of work. So I'm not expecting you to do this work because you would have to multiply by the conjugate, which is the opposite, and simplify a bunch. I'm not asking you to do that.
Thank you.
For number 5, you should have stopped right here. So everything else is extra. Now, I will say, depending on the angles you use for tangent, ours could be a little different. If you have 3s instead of 1s, that means we use different angles. As long as you evaluated those angles correctly, that's fine.
Wait, which one?
For 4 and 5, if you use different angles to get,
Wait, if I did. Is that wrong? I think I just completely wrong. I did.
this one I should have simplified differently, but I started doing something else. So if you have, you should really have wherever I split up the first one. This, and they may be 3s instead of 1s, depending on which one you use. I have to look at it to see where you are.
Wait, you should explain number 4. I was thinking this. I don't know what I did here. I think I listed up here. And this was bending backwards. Is that not true? Or is it I'm so confused. I really like this. And then I ended up getting so realistically, if you're adding these two,
That would be 17 pi is the over.
I did that. I don't know. I get confused when it's like
But 14 pi over 12 is 2 pi. It's 7 pi over 6.
You didn't simplify yet. You just didn't simplify correctly. I know we started the notes on the bottom part of the sum and difference last class. And we went over 3 of them. I don't remember.
Yes.
I want you to do the other 3, whichever 3 we didn't do. We'll go over those 3. The last 6 problems on your homework will be tonight's homework, if you haven't already done them.
Fresh in me. You probably leave you alone because you out and under the phone. Be glad she was gone. She wouldn't have to worry. She's crazy, but
You're gonna sign up. Alright, let me get your attention. You should have had these 3. So condensing them, tangent of pi over 4, sine of 16, cosine of pi over 3, and then evaluating 1 root 3 over 2 and 1 power.
If I just didn't finish the problem.
Questions on any of those 3?
You don't have to do anything with cosine or the sine one.
What do you mean?
If you don't break
Oh, like with the second part or with anything else? Because I don't actually know what the sine of 35 is or the cosine of 25. I'm condensing it so that I'm going back to the original. Going back to
Or
this.
so you don't know what it is?
when you but like how come you don't have to write cosine?
Because with these, you're looking for the formula. So this is sine's formula. This is cosine's formula. I mean, I can find it on the calculator. Alright, so far we've done reciprocal identities, quotient identities, Pythagorean identities. We started sum and difference identities, and now we're going to start our double angle identities. So, a way to remember these instead of just remembering another set of formulas, our sum and difference, we can use our sum and difference formulas and transform them into our double angle. So, you can use this box, but I'm going to use another page to do this part. So I'm going to rewrite this on a separate page. If you would like to know how to go from one to the other, this would be how you do that. Otherwise, you can just remember the formulas. So I'm starting off by writing the sum and difference for the sum for cosine, sine, and tangent.
What was that noise?
So if we are going to change our sum and difference to our double angle, one, if we're looking at the double angle formulas that you have, they're given to you, they all have theta. So that's what I'm going to do first. I'm going to change all my A's and B's to theta. I'm going to do this one at a time. So starting with, I'm going to do cosine last. Starting with sine, I'm going to change all of my A's and B's to theta. That was supposed to be the plus. That was my bad. How could I condense this?
Make twos. Like it says in the formula.
So really, once you add them, you get the formula. Yes.
Oh shoot, I ain't going another space.
We added them together.
Okay, wait, I have a question to ask. Okay, so since you added them together, you wrote 2 sine theta. Why won't cosine be 2 cosine?
Here, I'm really saying 2 of these.
Oh, okay. Okay, I'm sorry. I thought you. Okay.
So going from sum and difference for sine to double angle for sine, super easy. Just make all your A's and B's theta and combine. We're going to do the same thing for tangent. Make all of our A's and B's thetas. Just as we did with sine, condense, combine everything. So this becomes tangent of 2 theta 1 minus tangent squared theta, which is your double angle tangent formula. So you can use this, or you could just memorize another 3 formulas. It's really up to you. For cosine, same thing. Now notice that for cosine there are 3 double angle formulas. Well, the first one is found by just condensing. A big thing you need to remember here is that this looks very similar to your Pythagorean identities, but this is not because you're subtracting. So this is your double angle. When it's adding, that's your Pythagorean. But I can use your Pythagorean to change this. If you wanted to. I mean, you don't need to. I know cosine is 1 minus sine. So I can say another formula is 1 minus 2 sine squared theta.
Okay, I have a question. I'm completely lost now.
On what part?
Where's that 1 minus sine?
So that's a Pythagorean identity.
Okay. Oh, it's like you replace it?
I replaced
Okay,
it.
okay. Never mind. I got it. Kind of like 3, 4, 3.
We replaced it and
Okay.
simplified. We can do the same thing for sine. Sine equals 1 minus cosine.
Now you're just like redoing the problem as like another way? Is that what you're saying? Okay. And you can still simplify that, right?
Yes.
Okay.
So this would be 2 cosine minus 1. Almost the same thing as this one. Which is your third double angle for cosine. Now when we actually start doing this, you'll be able to use any of these 3. It won't matter. You can memorize 1, you can memorize all 3. You don't need to know all 3. You need to know one of them.
Okay, you're telling me that out of all those things we just did, I only need one.
For cosine, you only need to know one of them. You need to know
Yes.
sine and tangent.
Yes. Okay.
We don't really have time to start one of these problems, so we'll do that tomorrow. But make sure you do your homework. The last 6 problems on that same page.